Hello everyone, today I will present our EMNLP 2022 paper, Improving Large-Scale Paraphrase Acquisition and Generation. This is a joint work with my remarkable collaborators, Chao Jiang and Wei Xu. We believe human creativity is spontaneous. It cannot be forced. Imagine this scenario. You ask an annotator to write a paraphrase of "It's finally Friday, and I'm happy, as diverse as possible." Annotator writes "I'm so happy that it's finally Friday" without much efforts. Then you ask her to write another one. It's still doable but may take some thought. And then she gives you "I'm so glad it's finally Friday." But she realized that it's not much different from the first one she wrote. And what if you ask her to write another 5, 10, or even 20? This becomes significantly more challenging. And even if you have multiple annotators, it still takes a lot of time for them to write 10 diverse generations. And as forcing them is not a good idea, so can we find some spontaneous paraphrase data? The answer is yes. You can find them on Twitter. Every day, millions of people tweet on Twitter talking about a trend. For example, finally Friday. And besides trend, people also tweet about news articles like this. If we can leverage this data source, we can get a lot of diverse paraphrase. So let me introduce our data collection method. So we take this trend as an example, and we first group the sentences that are talking about this trend. And then we rank the sentences by the average word probability in the sentence, and this will bring sentences that are more related to each other to the top. And then we select the top ranked ones because the bottom ones are usually not related to the content that the top ones have, as you can see here. And we then find we then pair the top 2 sentences with the rest. And we ask 6 annotators to rate each pair on whether it is a paraphrase pair or not. And in total, we annotate data from 3,000 trends and 4,000 URLs, resulting in over 110,000 pairs. And our dataset covers multiple topics, so we call it multi-pit. And compared with previous works, multi-pit has much more diverse topic distribution. Specifically, majority data in PIT 2015 is about 2013 NFL draft, and majority data in Twitter URL is about 2014 US president election. With multi-pit, we fine-tuned some of the best pre-trained language models and 2x-LSTM models for paraphrase identification, which is useful for tracking information on Twitter. As you can see, pre-trained language models perform much better than by LSTM, and the Berta model achieves the best F1 score. And conventionally, people use the same dataset to do paraphrase generation, and paraphrase generation is useful for data augmentation, style transfer, and increased diversity of dialogue agents. Basically, people just simply remove the non-paraphrase pairs and train model with the paraphrase pairs. However, there's a problem. Both pairs are paraphrases as they convey the same main idea with some little extra information in sentence 2. However, this new information can lead generation model to hallucinate, which introduces unfaithful information. And that is really bad, right? And so we propose 2 paraphrase definitions, one for tracking information on Twitter and another one for paraphrase generation. And the only difference between them is that if the sentence 2 contains some info that requires fact-checking, then it is considered as non-paraphrase in the case of paraphrase generation. And we then ask expert annotators to annotate over 5,000 sentence pairs under the strict definition. And here's the model performance on multi-pit expert for paraphrase identification. And the model fine-tuned on multi-pit crowd, which is the first dataset that's annotated under loose definition, doesn't perform well. and this demonstrates the necessity of task-specific paraphrase definitions. But as it contains a lot of data, we want to think of a way to leverage it, and simply combining both crowd and expert data and train a model doesn't work. Then we use a noise training technique. So how this works? So we first have the ModelPit crowd and we pass it through the model fine-tune on ModelPit expert, and then we can get the model probabilities on the gold label, and we flip the label if the probability is less than a threshold. Here we use a 0.25 because it works best in a grid search, and then we combine this newly flipped ModelPit crowd data with ModelPit expert, and together we train a new model, and we call this new model flipping. You can see it achieves the best F1 score. And then we use this model to identify the paraphrase pairs from 2020 and 2021 Twitter data. And we call this new automatic identified paraphrase pairs ModelPit Auto, and it contains 290,000 pairs. And one thing to notice, as Twitter data is unlimited, ModelPit Auto is actually continually growing. And with ModelPit Auto, now let's train some of the best pre-trained language models on it to generate some paraphrases. And here is the test performance on ModelPit NMR, which is a multi-reference test set sourced from ModelPit expert. And the metric we show here is bird eye blue, which is a harmonic mean of bird score and 1 cell blue. It encourages both semantic similarity and diversity, and it is specifically designed for paraphrase generation and achieved the best correlation with human in its original paper. Across all models, T5 performs the best. And I know you like GPT-3, so you may ask about it. Don't worry, we also cover that. We try both zero-shot and few-shot setups of GPT-3 DaVinci 2. Turns out GPT-3 performs best. Is better than the fine-tuned models, which is not surprising given its size. And one thing to notice is that because we test models on our newly created ModelPit NMR test set, so there's no data contamination problem where the model is already trained on the test dataset. And another potential reason why GPT-3 is great is that some training prompt of InstructGPT or GPT-3 includes some rewriting tasks that are similar to paraphrase generation. And you may be wondering, is GPT-3 better than human? Not really. We calculate the cell blue for GPT-3 and humans. Cell blue is the blue score between the source sentence and output. The lower the score, the more diverse the output is. You can see that there is a huge gap between GPT-3 and human, showing that human writes much more diverse paraphrases. Okay, enough of comparing different models. Let's compare the generalizability of our dataset to other popular datasets. So we fine-tuned T5 large on MS Coco, Quora, and ParaMT, and evaluate them across datasets. And here are the results. Each plot shows the model's test performance on that dataset. For example, the first plot evaluates the model trained on each dataset on MS Coco test set. And in domain, models always perform the best, as you can see here. And MS Coco and Quora models don't generalize well compared to ParaMT and the ModelPit Auto models. And this is because they either contain only image captions or questions. And here's an example from model fine-tuned on MS Coco, and another example from model fine-tuned on Quora. You can see they either generate the paraphrase in a format of image caption or question, and they are not very good. And what about multi-pit auto and ParaMT? As you can see, it is hard to distinguish them under automatic evaluation. So we conduct a human eval on these two models. The model trained on multi-pit auto performs better in all three aspects, especially on diversity. This might be because ParaMT is created through back translation. I know you need more evidence, so let's peek under the hood. And here we show 3 input sentences and model generations on them. And the multi-pit auto model makes more significant and interesting changes than the ParaMT one. So what are the takeaways? In this paper, we utilized the spontaneity in Twitter to get high-quality paraphrases. And we introduced separate paraphrase definitions for identification and generation purposes. And experiments show better generalizability of the generation models trained on our dataset than on other popular ones. And please don't forget to check out our webpage. It has everything you need, paper and all the datasets. Thank you.